We have the chemical properties of chlorine gas. The first one is reaction of chlorine with water. When in Form 2 dealing with halogens, we covered this area. And you remember we mentioned that chlorine dissolves in water to form a colorless solution of chlorine water. Although sometimes the chlorine water has a pale yellow color. Chlorine water is a mixture of hydrochloric acid and chloric 1 acid. When chlorine reacts with water from this equation, you will find that it forms a mixture of HCl, which is hydrochloric acid, and chloric 1 acid. Chloric 1 acid is very unstable. And decomposes in the presence of sunlight. And that is why, if you're carrying out the experiment of dissolving chlorine in water in the presence of some sunlight, the solution will be colorless. Let us have some mind gym. Study the figure and answer the questions that follow. First question. Name gas X. State and explain two observations that would be made. Then write an equation for the formation of gas X. Since this is a mind gym, I'll leave it up to you. Find the answers. The bleaching action of chlorine. When you're talking about the preparation of chlorine, I mentioned that moist blue litmus paper is placed in the mouth of the gas jar, and when it turns red and then bleached, it will indicate that the gas jar is full. So why was the moist litmus paper bleached or decolorized? Moist blue litmus paper is decolorized because the chloric 1 acid formed when chlorine dissolves in water is a very unstable compound and readily gives up its oxygen, especially when exposed to sunlight. In the process, the green-yellow solution is decolorized. The equation for this reaction is as follows. Chloric 1 acid in chlorine water, when exposed to sunlight, decomposes to hydrochloric acid and oxygen gas. The chloric 1 acid, when it loses its atomic oxygen to a compound that contains some color such as a dye, the dye will be decolorized because of the formation of a colorless matter, according to the following equation. So chloric 1 acid decomposes to give off oxygen, and the oxygen combines with the dye to form a colorless matter. Next is the reaction with hydrogen. What do you think is the product formed when burning pure hydrogen in chlorine? If you said hydrogen chloride gas, then you're right. Chlorine reacts with hydrogen in diffused light to form hydrogen chloride gas. It is important to note that this reaction is very explosive when in the presence of bright sunlight. However, in diffused light, the reaction is much slower and gentle. This reaction cannot take place in the dark. Next is the reaction with hydrogen. Now we have reaction of chlorine with metals. We have already covered these in previous topics, and you know very well that chlorine reacts with metals to form, yes, metal chlorides. So what do you think is the product formed when burning sodium and chlorine gas? If you said sodium chloride, you are right. The question is as follows. Other metals that can be used include iron, which forms iron 3 chloride. And 3 chloride is formed because chlorine is a strong oxidizing agent, and therefore iron 2 chloride cannot be formed because any iron 2 chloride formed is quickly oxidized to iron 3 chloride. Another one is aluminium chloride. It is important to note that aluminium chloride and iron 3 chloride sublime on heating. While sodium chloride does not. Other metals that can be used include copper, zinc, or an alloy of the two, which is really called Dutch metal. This one will burn in chlorine a green flame because of the copper present. After the discussion with the reaction with metals, we go on to the reaction with non-metals. Again, what do you think is the product or products formed when white phosphorus is lowered in a gas jar full of chlorine? Now, phosphorus and chlorine react very vigorously, and it does not even require any heating. So when you're carrying out this experiment, lowering white phosphorus in a gas jar full of chlorine, no heating is required. So the products formed are phosphorus reacts with chlorine to form phosphorus 3 chloride and phosphorus 5 chloride. These two reactions take place at the same time to form a mixture of the two compounds. Similarly, chlorine reacts with liquid sulfur to form sulfur monochloride dimer, which can also be called disulfide, dichloride. Reaction with reducing agents. One of the unique properties of chlorine is that it acts as an oxidizing agent, and therefore it reacts with the reducing agents through redox reactions. Oxidation reactions of chlorine involve hydrogen sulfide, sulfites, and ammonia. Now, when chlorine is added into a gas jar or a test tube full of hydrogen sulfide in a setup that looks like this, there are several observations that would be made. When chlorine reacts with hydrogen sulfide, it forms sulfur and hydrogen chloride gas. Hydrogen chloride gas is colorless, while sulfur is a yellow solid. Therefore, at the end of the experiment, some yellow deposits will be formed at the bottom of the test tube. These yellow deposits are sulfur. And then a colorless gas, of course, of hydrogen chloride gas will be observed. Now, in case there is some moisture inside here, then hydrogen chloride gas will form some white fumes of HCl gas. This delivery tube is taken to a fume chamber. Next, we have the reaction with sulfites. Since chlorine is a strong oxidizing agent, then it would oxidize sulfites to sulfates. So when chlorine is passed through sodium sulfite, it oxidizes the sulfite to sulfate. And the equation is represented as follows. Sodium sulfite, take note of the formula, reacts with chlorine in the presence of some water, which is dissolved in the sulfite solution. We have sodium sulfate and hydrochloric acid. Similarly, potassium sulfite reacts with chlorine and some water to give potassium sulfate and hydrochloric acid. Next we have the reaction with ammonia. Ammonia burns spontaneously in chlorine, and in the process it is oxidized to nitrogen and hydrogen chloride gas. So when ammonia burns spontaneously in chlorine, nitrogen gas and hydrogen chloride gas are the products. Next we have is the reaction of chlorine with hydrocarbons. Do you remember what hydrocarbons are? These are organic compounds that contain hydrogen and carbon. Some hydrogen carbons burn in chlorine to form hydrogen chloride gas and carbon. Ethane, which is a hydrocarbon, reacts explosively with pure chlorine. Remember, it must be pure chlorine. In the following reaction, ethane, which is written like this, reacts with chlorine to form carbon and hydrogen chloride gas is liberated. The reaction of chlorine with alkali solutions depends on the temperature and concentration of the alkali. To begin with, if the alkali is cold and dilute, then the reaction takes place as follows. Sodium hydroxide, which is a strong alkali, reacts with chlorine to give two products, sodium chloride and sodium hypochlorite. And the other product is water. However, if it reacts with hot and concentrated alkalis, the hot and concentrated alkali will decompose the hypochlorite to a chlorate and a chloride as follows. Sodium hydroxide, when it is hot and reacts with chlorine to give sodium chloride and sodium hypochlorite and water at first. But then, since it is hot and concentrated, the sodium hypochlorite that is formed is decomposed to sodium chloride and sodium chlorate. So the overall reaction would be as follows. Sodium, when it is hot and concentrated, sodium hydroxide reacts with chlorine to form sodium chloride, sodium chlorate, and water. That is obtained by combining these first two equations. Displacement reaction with halogens. Chlorine is a halogen, and it can react with other halogens such as bromine and iodine. As you remember, the rule is that the more reactive halogen, displaces the less reactive halogen. So let us begin. Chlorine has the ability to displace bromine and iodine from their compounds. When chlorine is bubbled through a solution containing bromide ions, the colorless solution turns orange. Chlorine has a higher tendency to gain electrons than bromine, and therefore it readily oxidizes bromide ions to bromine. So bromide ions are readily oxidized to bromine, while chlorine, of course, will be reduced to chloride ions. Similarly, when chlorine is bubbled through a solution of iodide ions, the colorless solution turns brown. Chlorine oxidizes iodide ions to iodine. In the presence of iodide ions, then the solution is a reddish brown solution. It can be represented as follows. Next we have is the reaction with slaked lime or calcium hydroxide. Calcium hydroxide is also an alkali. It reacts in a unique way. So chlorine can react with slaked lime both in solid form and in suspension form. The equation is represented as follows. Calcium hydroxide reacting with chlorine to form calcium hypochlorite. This one is known as bleaching powder. Which can be sold and packaged in different brands.